VPC, what is a virtual private cloud, what are subnets, what are internet gateways, etc. Right. So we're going to learn about all that. So let's say, guys, that you have a particular organization which is creating its resources on the cloud on AWS. So let's say that that particular organization is something like, let's say, Accenture. So we know that a company like Accenture has several offices all over the world. And let's say that there is another organization here. Let's say something like Deloitte, maybe. So if you have these two organizations, guys, at any point in time, guys, just imagine, let's say that any point in time, these both organizations are running several servers and several databases on their systems. Let's say these are some servers, and so here on the Deloitte side also they have some servers. And same way, guys, let's say that here you are having some databases. Okay, let's say that here also we have some databases. So, guys, do you think that it would be practically acceptable that the users or the organization Accenture, from Accenture, you are able to access all the databases of Deloitte, or Deloitte servers are able to access the databases of Accenture, and these servers are able to access these servers? Is that practical? Is that acceptable, guys? Would any organization agree to something like that? No, correct. But guys, these organizations are all creating their infrastructure on AWS itself. So they are all on AWS. So actually, even though it's Accenture and Deloitte infrastructure, but overall they will be creating their infrastructure on AWS. So that's why AWS, because the entire all the organizations are entirely on AWS. AWS has to ensure that something like this does not happen, right? If one organization is able to access the data from other organization, because of the data security breach, the entire system will be, brought down. So they will just shut down the entire system. So that's why in this case, we have to make sure that the systems for Accenture and Deloitte, is designed and created in such a manner that by default, they cannot access each other at all, right? They should not be able to. So although they have been created on the same platform, that is AWS, they should not be able to access each other's resources no matter what happens, right? That's why, so even though we are all using the same AWS, so we are also creating our free accounts on AWS, right? I am also creating certain resources, you are also creating certain resources. So it shouldn't happen that our resources, so it shouldn't happen that from yours resources, my access resources are accessible and so on, right? It shouldn't happen that way. So for that, we make sure that you are always ensuring that your systems are designed in such a way that you do not allow any other systems to be accessing it. So how do we create the infrastructure in such a way, guys, that the systems are totally isolated, that one user's system is not able to access the other user's system? So that's what we are going to see. And for that, let's say now you have a particular scenario where you are creating these different types of systems for the different organizations. Okay, and this by using this type of a networking concept, you are able to separate the different organizations or different account details. If, for example, if my account has certain resources, you can separate it from other accounts by creating your resources in a certain VPC, or you can say a certain network. So let's say exactly what is this. So I'm just going to give you a practical analogy or just a practical example so that you can understand this. Let's say that this is the AWS infrastructure. Okay, so if you have to compare it with real world example, I can say that this AWS infrastructure, you can compare it with any real world scenario. So let's say that this entire thing is like an apartment building, right? So it's like a apartment building where there are many residents living. So here, guys, within this building, let's say you have several apartments, right? Or you can say several houses are there. So let's say that there are several houses. Now, in these houses, guys, there will be different types of families, right? Different types of families will be there. So let's say here on this side, let's say that there is a very small family with just a husband and wife and maybe one child, right? So this is a family. And in this place, let's say that there is just a couple. Okay, so here you have a small family, here you just have a couple. Maybe here a bachelor is living alone. Maybe here another couple. Let's say this is how the entire apartment building is at present. Okay, so now although guys, if you see all these people, although they are within the cloud, guys, you can create different types of, so every time this VPC you are creating, this is an isolated, totally isolated resource for your systems, right? So although you have the entire AWS, right, you have the entire AWS environment. This is one particular organization's VPC, right? So this is the entire AWS environment, and within the AWS environment, Accenture has its own VPC. Then you will have Deloitte, which has its own VPC. And because guys, they have their own VPC, whatever resources they're going to create will be within the same, it will be within the boundaries of the virtual private cloud. That's why it will never be going out, right? Just like we saw here, although the same apartment building, there are different houses and they can do whatever they want inside their house. Just like that, here also, you have the AWS environment, the entire environment, and there you are creating different VPCs. And within that VPCs, the different organizations are now creating their resources. So once this is done, guys, because these are isolated environments, one department will never be able to access the other department. One organization will never be able to access another organization. So same way that the accounts that we are creating, when I create my account, when you are creating account, they are also completely logically separated. So by default, nothing will be able to access each other. So this VPC that we create, guys, this is actually called as the large network, right? It's actually called as the large network belonging to a particular organization. It's called as a large network belonging to a particular organization. So when we say large network, that means there will be a smaller network as well, right? So yes, you can use the large network to create multiple segregations within your network. So let's say for a particular organization, I have this VPC. So let's say that this VPC or the virtual private cloud belongs to one particular organization like Accenture. Now this Accenture will be able to create this, will be able to divide this large network further into smaller networks. So here, this is called as the large network, I can say. Within this large network, there will be smaller networks. So when you are saying this VPC, virtual private cloud, within this, guys, we create something called as a sub network. So if you remember, guys, I had given you 3 different articles. In those articles, guys, one of the article was called as subnet. So here you have the virtual private cloud, you have the large network within which you can distribute it, right? You can divide it up and you can create multiple smaller networks, right? So they can be called as the smaller networks, or you can also call them as sub networks. Just to keep it simple, we call them subnet. So what is subnet? It's a smaller network. Subnet is called as a smaller network. So let's say that for one organization, you are creating the VPC. For one particular organization, you're creating the VPC, which is a large network. So this large network belongs to the organization called Accenture. And within that, you have the different sub networks, right? So this could belong to some specific department like sales department, right? Or this can belong to some other department. Now, why would you need this large network and these smaller networks? Why would you need? Because there will be different types of data, there will be different types of access patterns, there will be different types of departments for which you have to separate the way that they access the data, right? You have to separate the way that they access information. So let's take a scenario base. So just like we discussed about that network, let's take a scenario where you have a particular organization which has posted all its data on AWS. Okay, so they have posted their data on AWS, and now they are, in a way, planning and seeing how they can manage it. So let's take the example of a particular organization like Flipkart.com, right? So in case you don't know about Flipkart.com, it's just a shopping website. So it's just like a regular shopping website where you can go and put in some data and you can just access different types of information. So in what IP addresses do they get? That's what it defines. First, you have to give an IP address range for the, then you will give an IP address range for the subnets. Then you will create the different servers within that same IP range. Okay, so let's see. Once we see it practically, then you will understand. So let's say that this is the VPC. Okay, so you can understand that this is like the large network, right? So here, guys, you are going to give this a particular IP range, private IP range. So that I told you guys that there are two different types of IP addresses. One is the public IP address, right? And one is the next one is the private IP address. So public IP address and private IP address. So these two IP addresses, guys, the public IP address is used to access the resources on the internet. The private IP addresses are used to access the resources within a private network. So if you see on my system, on my laptop, if I go into this command prompt and I check the IP config, so I'm not sure if I've shown this to you guys. If I come here and I say IP config, this is the command that I give. So here, guys, if you see, there is an IP address, right? So this IP address, guys, is a internal private IP address, right? This is an internal private IP address. If you see, it says here wireless LAN adapter Wi-Fi, right? So the wireless local area network that I'm connected to, right? The wireless router that I'm connected to, that device has given me this IPv4 address, right? It has given me this IPv4 address, and using this address, I will be now able to communicate within my network. So let's say that in my own internal network, like an office network or home network, this IP address is used to communicate, and at least with the router also. But if I need to access the internet, right? If I need to access the internet, I'll require a different IP address. So this is called as a private IP address. And in that case, I will require a different IP address, which is called as a public IP address. How do I find that out? There is a website for that. It's called as whatismyipaddress.com. So if I refresh this, you'll see that it will show you your IP address. Okay, so if you see here, this is the IP address that it gives to me, right? So this is my public IP address, the public IP address which I can use to go and access the internet. So I cannot access the internet with this IP address because this is an internal IP address. So yes, so the public IP address that I get is from the service provider. The internet service provider will be giving me an IP address. If you actually scroll down on this page, guys, it will give you all the details about my service provider, exactly what is my location. So you can check it out on your system itself, guys. What is my IP address? You'll see that it knows exactly where you are located, what is your IP address, what is your location. Everything is based on the service provider details that have been given, right? So the service provider is able to track you easily based on that. So now, why do we need these two different IP addresses, guys? The internal IP address is for the internal network communication. Whenever you want to access the internet, you need this public IP address. So one IP address belonging to one device. But when I'm taking this /16, I'll show you in detail how. But this /16 means that it's a collection of multiple IP addresses. That means within this /16, there are several subnetworks. Within those subnetworks, there are several systems. There are several servers as well. Okay, so this is an entire address space. That means it is a combination of several different devices put together. Okay, so let's see. Now I'm going to explain that in more detail, guys. So let's say that I've to my large network, I have given this address range. So when I create my subnetwork, right? When I create my subnetwork, the subnetwork will be based upon the same larger network. Okay, the subnetwork will also have an IP range, which will be based on the exact same range. So this subnet, guys, what it will do is it will take the first two digits. Okay, it will take the first two digits of the large network, which is 192.168, right? So it will be like this. First two digits will be taken. The third digit will change, right? The third digit will identify the specific subnet. Okay, so the first two numbers will remain the same from the same VPC, and the third number is what identifies the specific subnet. So let's say that it is 1, and the fourth number will remain as 0. And for the subnet, just like, for the VPC, we have /16, right? For the subnet, we will have /24. Okay, so here we have 192.168.0.0. So because the subnet is within the VPC, the first two numbers are going to be the same. It will be 192.168. And then you will have 1 is the designated number for the particular subnet. And then 0 will remain. And then you have /24. So if I follow the same rule, guys, let's say if I have to create another subnet, can you tell me what would be the IP address range for this subnet? You have to follow the same rule. First two digits have to be the same. Okay, 192.168 dot. So first and two numbers will be the same. 192 and 168 will remain the same. Then you give the third number specifically to the subnet, right? So the subnet is defined by this 2, and then you have .0/24. Okay, so now how do we get this 24? So just like, how we got the /16, I'll also explain this. So what is /16? What is /24? I'll explain that to you in detail. But right now, the basic understanding is you get the first two digits from the network, large network. Then the third digit is what defines the subnet. So you just put the first number. Now, if I create a server within this, guys, okay, if I create a server within any one of these subnets, let's say I create a server here in this subnet. Okay, if I create a server in this subnet, what will be the IP address? Here, the same concept is repeated. Okay, the concept is you have the 192. So from the large network, from the VPC to the subnet, what did you do? First two numbers were the same, right? They were common. So 192.168. Here, from the subnet, when you're deriving the server, when you're keeping your server in the subnet, the first three numbers will remain the same. Okay, so this will be like this: 192.168.1. Okay, so the first three numbers will remain the same, and the fourth number is what identifies the specific server. Okay, the fourth number identifies a specific server, so it will be just one. Okay, so 192.168.1.1, right? And there won't be any other extension for this. It's just /32, which can be ignored. Now, let's say, guys, I have another server here in this subnet. Based on what we saw earlier for this first subnet, can you tell me what would be the IP address for this server? It would be 192. So the first three numbers will remain the same, right? So 192.168.2. So all these three will remain the same. Then the last one will be .1. Okay, so 192.168.2, and the fourth number is what defines the server, right? So the fourth digit can be 1, 2, 3, 4, whatever it is, right? So how many can there be? We will see that in detail, right? So this is how you derive the IP address range of the subnet from the VPC, and you derive the IP address of the server from the subnet. Okay, so what is this /16? What is this /24? We will understand that in detail. So let's see, guys, how do you actually get this IP range, right? So what is this IP range? Okay, let's say you have this IP address 192.168.0.0. So this IP address you have to convert into binary. First of all, for that, guys, we get something like a decimal to binary converter. Okay, we get a decimal to binary converter. So what is binary, guys? Binary is nothing but a number is represented in only ones and zeros. Any specific number can be represented by only ones and zeros. That is called as binary. So if you want, you can read about it more in detail later. Right. So here now we are going to create our own VPC. Correct. We are going to create. Sorry about this mess, guys. I'm sure to remove this. So we're going to create this large network first, the VPC, and then we are going to create the sub network after that. And then we are going to create the servers within that, right? So why do we need this? So we need this so that we can create our own customized network on AWS, right? So what happens is when a particular organization, guys, when they have their own on-premises physical network, right? When they have their physical network, on-premises network, they would already be using a certain network IP range, correct? So when they are migrating all their services from the physical on-premises network to the cloud, they would require the same IP address range on the cloud also, right? On AWS also, they would require the same IP address range. That's why we have to create our own network. In many cases, guys, there is something called as a default network, a default VPC. So, guys, why do we have a default network? So if you remember, guys, when we created the servers initially, when I showed the web server to you initially, I created a website and gave you the IP address. If you remember, guys, over there, I didn't create any network, right? I directly went in and I just created a server, and immediately I was able to access the server. Why? Because when I go into this VPC, guys, in this VPC, there is something called as a default network, which is available. Let me just go into another region. So if you see here, guys, it shows the VPCs as one. Okay, so there's just one VPC which is available. So by default, there is already a VPC available. How do I know this? If I scroll to the right, you'll see that it shows here default VPC, yes. Okay, default VPC, yes. That means this VPC is already available. I didn't create this VPC. Okay, this VPC is already available. Why? Because in every single region, AWS gives a network by itself, right? It creates and gives us a network by itself. Why? Because as solutions architects, guys, you and I, we will be creating networks. We will be working on different types of services because we are going to be solutions architects. We are going to be designing networks for different customers. We will be doing that. So we know very well how to create a network. Very soon we'll know how to create a network. How do you create sub networks and all that, right? But let's say there is someone who is majorly focused on creating or developing websites, right? So their focus is more of developing websites and developing different applications. So those people are not really focused on creating networks and all that, right? So they don't know what is a network, they don't care what is a network, subnetwork, they don't have time for all that, right? So they are focused more on creating their applications. But for testing their applications, for testing their websites, they need the infrastructure. They do need a network connected server where they can host their website and check if it is working properly or not, right? So when they are going to use AWS to check their websites,